Thank you, Julie. Welcome, everyone. It's great to be here with lots of sustainability love on this day. In today's conversation, we're going to dive in much more deeply into the campus as a test bed. And just scanning the room, just curious from a show of hands, if you're familiar with the term campus as a test bed. Okay, so a number of you are familiar. Hopefully by the end of the panel today, you'll have a deeper understanding of what that means, and you'll all be very eager to engage even more in the campus as a test bed. Through the sustainability, and I'll introduce a panel in just a minute. Through the sustainability data pool, the campus sustainability data has been aggregated and it's been made available for use in classes, research, and capital projects. And these are examples of how the campus as a test bed manifests itself here on campus. The campus is informing the development of solutions well beyond campus through large-scale renewable energy power purchase agreements. Courses are engaging the campus community in solving for sustainability. Energy modeling is informing campus infrastructure approaches and solutions. And today, joining us on the stage, I'm really thrilled to have some of these folks in person. These are the human faces of the campus as a test bed. We're going to hear shortly from Dr. Ken Strzepek. Ken is a research scientist with the MIT Center for Global Change Science. He's also an Office of Sustainability Faculty Fellow. And you'll learn more about how Ken is leveraging the campus as a test bed for modeling a climate-resilient MIT. Following Ken, we're going to hear from Dr. Miho Mazereeuw. Miho is an associate professor in the School of Architecture and Planning. Miho is also the director of the Urban Risk Lab and also an Office of Sustainability's faculty fellow. And Miho is going to share her perspectives, which are really broad and diverse, on how she's engaging students in data collection, material reuse, and landscape design. And then finally, we're going to hear from Ippolyti Dellatolas. Ippolyti is a current PhD student. She's been advancing through her research efforts to both energy model parts of the campus and also analyze how federal policy may be able to assist campuses in decarbonizing. So save your questions. We're going to allow time before the end of the panel, and we'll have some microphone runners so you can follow up with some questions to pose to the panel. So let's get started. Ken, you have worked all over the world, and you have spent quite a bit of time traveling and working all over. You live in Colorado, and for the past 5 years, we've been working together on the campus as a test bed. I'm really curious to hear how you've done that. And then just to flag that I didn't know anything about Zoom until 2017, when Ken introduced Zoom to our office because he had moved. And we became really proficient on Zoom in 2017. And you've always been ahead of your time, Ken. You've always been cutting edge. Now, can you be ahead of your time and take 3.5 minutes and walk us through how you've leveraged the campus as a test bed? And if you need to take a little longer, that's fine too. All right. And I will advance your slides, but walk us through. And I know it's behind you, so it might be a little awkward. But Ken, how have you leveraged the campus as a test bed? And can you tell us a little bit about why you've chosen to do this?
Great. Next slide. So, as part of research, Professor Carrie Emanuel and I had been working on research and development support for the World Bank around the world on the risks of climate change to coastal flooding. And we would travel from Cambridge around the world, but never looking at home. Next slide. But then in 2015, the city of Cambridge undertook a climate change vulnerability assessment. And one of their activities was to look at heat, but also to look at the flooding risk. And one of the conclusions of that study, which you see there, is the campus is all gray, the campus there along the Charles. And so their conclusion was there's no risk to MIT but with flooding currently or in the future. So Carrie said, well, let's use his techniques to look at this to see maybe that's the way that they had studied it. So then we started to undertake that. Next slide. What we found out is there is a huge risk to the campus, and one of the reasons was the campus is 10% of Cambridge, and the major drainage for the campus is privately owned by MIT and was not in the database that Cambridge used for modeling. So what happened was we found out that there wasn't just a climate change problem, there was uncertainty and lack of knowledge about how much at risk the campus was to flooding. So we undertook as a team through MITOS, and also the Climate Resilient Committee was started. And so as one of our first activities, instead of looking to the future, we looked to the current. And then with Joe Higgins and a number of other people from the Office of Facilities, we were able to get data and to build a new model. Next slide. So we extended the work of Cambridge and built a model of the MIT campus, which needed extensive data. So over $500,000 was spent to understand what these pipes were, because there was no data on them at all. And we were able to build the model, and we found out there is quite a risk to the campus. And it's a very elaborate risk and complex risk of rain falling on the campus, rain coming from upstream on the Charles River, and then sea level rise and storm surge and all of those things. So we had to do that systemically. Then we started to look at it as a research side in terms of the future. Next slide. So one of the things we found is, as we were doing this study, is that the current state of the art of engineering and science on climate urban risk could not answer the questions of MIT. So partnering with our friends at the Department of Insurance and at facilities, the consultants couldn't answer those questions. So what we did is there was a number of areas we had to go and start studying. So next slide. So what we did is develop partnerships. So the whole key about campus as a testbed are partnerships. So we developed partnerships with the Office of Sustainability, with facilities to help answer these questions. But then there were research questions. So we worked with a number of faculty, with campus researchers on board. But more importantly, as the goal of Julie and the Office of Sustainability is education, research, and operations, we brought students in. So it was bringing faculty, students, and operations together. And we went and had a number of activities. Next slide. So one of the key things of this is, as we were going through, and we can talk about the details later, but one of the key identity things was that basements are a real problem on campus, because on the main building, they're 3 feet above, the first floor is 3 feet above the ground, so it's the basements that are at risk. But then on MIT campus, we have the unique thing of 33 buildings on east of Mass Ave being all connected. So the risk somewhere far away may actually be from water moving under the ground. This was never done before. So Katya Boykin, who became an MITOS fellow, she's a PhD student in civil engineering, she needed data. That data wasn't available, and it was almost 3 minutes, $3 million, $300,000 to gather it. So she got together a group of undergraduates, designed a program to gather that data so we could do that modeling. Next slide. And so what did it do? This research work has been presented at almost 9 conferences. There's 6 journal articles in the work. And more importantly, all this research has been transferred to the consultants that are working with the facilities for the roadmap on how to be sustainability. And we've passed that off, and it's now actionable. Thank you.
Thank you, Ken. That was speedy. And we'll come back to some more questions to understand a bit more about that. Thank you. Miho, it is wonderful to see you here in person. We're so glad you could join us. Through our years of working together, I've been really inspired by your work. Your method is you solve these real-world challenges, and you somehow find a way to engage students, engage technology, and engage spaces, both indoors and out. And it's a fantastic method that applies really well to the campus as a test bed. With so many demands on your time and so many things you're interested in, can you tell us, why are you involved in campus as a test bed here on campus, and what have you been doing? How have you been engaged in this work?
Thanks, Brian. Thanks for inviting me today. I'll start with the first question of some of the small projects we've been doing and then answer the last question. We accepted the baton from Ken's work, looking at campus and potential flood hazards, and then, yep, oh great. And so then we needed to go more granular to understand where are the openings, where is the porosity within the buildings on the campus. And so we developed this little software platform and we engaged students. And the first job was to then figure out, oh, thanks, now they're my slides, okay. The first job was to figure out within the Cambridge datum line where the buildings sit. And so we have so much information on each building, but where they sit within the Cambridge datum, we had to go then and measure through each. And so all the red dots are measurements. Next slide, please. And so with the group of students and the little software platform we developed, we went around and we actually looked at each window and each vent and each opening that was subgrade and that could have all this water pouring in. And the type of window, the condition of the material around it, and what the vulnerability is. And so with a few groups and lunch provided by MITOS, thank you. It's always great to have students gather around food too. We measured over 1,000 openings, and then this information then fed back into Ken's model. So that's the first project, which really is important to engage students, to really have them also looking at these kinds of openings around their homes, around campus, so they have this ownership and stewardship of their environment around them. Next slide, please. Another small project, but growing. This is within SAMP in the architecture department. We started this collective material reuse. For those who are not familiar with the architecture program, we build a lot of models, use a lot of wood and plexi and expensive materials that not all students can afford. And at the end of the semester, our scraps just get thrown out. And so it seems simple. There's a need. There's a waste. Let's connect those two together. And we created this system with Amanda, Zoe, and Evelyn, 3 students last year. And this year we have Amanda and Dewani joining us, who is somewhere here as well, as she's a MITOS RA. Next slide, please. And so last spring, we collected over $3,000 worth of material that was then redistributed to students in need in the fall, and we color coordinated everything. And thanks to Jim Harrington in SAMP, we now have a dedicated space. We were all mobile little carts and things until now, and now we have a dedicated space within the studios for this, and so hopefully it becomes a program that continues. And I think with this, it's also sort of modeling the behavior that Julie was talking about. Like, I'm a busy professor, but I still have time to rescue a big piece of plexi out of the trash and bring it over here. And so it's trying to get students to be involved in this, and I think especially on the receiving end, a lot of students are appreciative, and so hopefully this kind of continues the cycle. Next slide, please. I don't know how I'm doing on time, but this is something that we'd like to start working on this summer. We've started briefly, next slide please, analyzing all the buildings on campus and the amount of sun they receive, and knowing that there are heat impacts to the people who are working within those rooms. So this is just an analysis, and we've started walking around looking at all the facades and understanding beyond the heat gain, what is behind, who is working within those offices behind those windows, and then what is the window fenestration structure around it. And we want to connect this heat risk with food insecurity in a way where then we can just grow, next slide please, grow vegetables and fruit so that students can harvest them over the summer. And we can, we're doing this all in potted plants, and so it's really a temporary installation that will get installed early spring to late summer. We'll harvest it and then take it away. So we're in the process of speaking to many of you to get your advice and your feedback and permission on this project, but we have an eager group of students. And then also all of us in the Risk Lab, one way we manage our stress with other projects that are really serious global issues like what's going on in Turkey right now, and how we manage our own stress is growing little plants within the lab. And so we will be starting these seedlings in March. And so also any of you who have a sunny window box who'd like to join in growing seedlings for the campus, we welcome you to email me. And this is my campus not campus as a test bed, but my balcony as a test bed over the last 2 years with little cucumbers and also melons and watermelons. When they grow up, they are very small, but they're just as sweet and delicious. And so we hope to have this on campus. And I have 0 minutes, and so I will conclude here.
Thank you, Miho. We look forward to diving in shortly in the rest. Ippolyti, so glad you can join us and represent, as one student, the collective sort of body of so many of our student contributions. But specifically, Ippolyti, your ability to leverage your skill sets is really impressive, both as a PhD candidate in mechanical engineering. You've done some energy modeling with us, and you've also been conducting this federal policy analysis. So you're an invaluable contributor, and we really look forward to hearing from you now. How are you leveraging the campus as a test bed? And also perhaps a bit more about why you've enjoyed it and found value.
Yeah. Well, thanks a lot for having me here. So as Brian said, I'm a PhD student in mechanical engineering. I do experimental physics in a lab. It's a big lab space. And in parallel, I've developed a strong interest in science policy, which led me to do a fellowship at the National Academies, where I really got to experience firsthand federal policymaking. And I guess that the way that I've used the campus as a test bed kind of mirrors these two aspects of my background. So on one hand, kind of considering technical solutions to emissions reductions in buildings on campus, and then on the second hand, like looking at how policy at different scales, so federal, local, and city, can impact MIT and how MIT can leverage that policy. So next slide. Yeah, so first, as part of a class project, actually, a class that Julie taught, I started doing some energy modeling on lab emissions. And I figured that you could get significant emission reductions from equipment upgrades, particularly equipment that consumes a large amount of ventilation. And doing a cost-benefit analysis on that, I found that the return on investment for the Institute was actually at a very short time scale, and managed to secure funding from the administration to launch an energy savings pilot program in Building 18. So that's the chemistry building, which is quite, it has a lot of fume hoods, so these large equipment that absorb a lot of air and that actually consume a lot of energy. And so we started that. Next slide. Yeah, so on the policy aspect, well, in the past year, most of you probably know that there's historic legislation that has passed at the federal level through these 3 bills there. There's a huge amount of federal funding, kind of unprecedented, for things including infrastructure upgrades and also climate action. So the passage of these bills is a huge achievement, but it has also been described as the end of the beginning. So all of this funding is only good if it's well implemented. And so that's a huge amount of work that needs to be done, and something that MIT was also very interested in. And so I did a bit of analysis of the Inflation Reduction Act in particular to see how MIT could leverage the provisions of the Act for its own decarbonization goals, both the 2026 net zero goal and the 2050 zero emissions goal. And this includes considering how MIT can leverage financial incentives, but also what community partnerships MIT can do based on the provisions of the bill. And then it was also important to us to kind of share these findings with other institutions of higher education. And so we put out a paper that kind of summarizes that in collaboration with the Aspen Institute and Second Nature. And we also shared the findings in a webinar. Next slide, please. So going forward, I'm now working with Julie to consider new ways that we can kind of coordinate campus as a test bed efforts, because there's a lot of things that are going on, a lot of bottom-up initiatives that would be really, really nice to scale. So that's one thing, and I guess to answer your other question, what I've learned throughout this process is really the value of being able to interact with key actors and stakeholders across campus. So I've worked with a lot of different groups, facilities, EHS, faculty, other students, and that is really, really important in getting things done and getting things done well, because all of these groups have different expertise. And finally, I've really been thinking a lot about the importance of public engagement, so including all of these groups from the onset of establishing a decarbonization strategy and looking at the impacts of the implementation of that strategy. And then when we consider campus as a testbed initiative, so like pilots, really being super transparent about our findings, and it's a learning process and sharing all of the knowledge that we acquire when doing that. Yeah.
Thank you, Ippolyti. We'll hold there. And a few questions, and then in the audience, if you can kind of prep up your questions, and maybe we'll turn that off for a second. We'll come to you in just a few minutes. Ippolyti, you touched on this a bit. From a successful point of view and a personal point of view, kind of what is it that really compels you to engage in a campus as a testbed project? And then what does success look like to you?
I guess it's the idea that there's actually a lot of things that can be done, and the barriers to implementing new strategy are actually quite low. It's more about figuring out who to talk to, and yeah, in that sense, a successful campus as a testbed project is either in terms of the output. So for example, okay, we achieved like these many greenhouse gas emissions reductions, or we learned something really, really valuable in the process. So even if it kind of fails from a emissions point of view, we still understood why it failed, and then we can transfer that knowledge to the next thing that we're going to try, for example. Yeah.
Thank you. And I think I'll come and sit because I feel like I'm blocking you all from this side. Ken, how about you? What does success look like in a campus as a testbed? And then what kind of ingredients? You've found a lot of success, but what does it look like, and what are those key ingredients that are required?
So there's been a range of things. One of the biggest success was having been here as a student starting in 1972 and then leaving in 1980, working with the Department of Facilities and all the other operational aspects of MIT to see the dedication and the commitment and the dedication to go beyond what is state of the art, because we're at MIT to be an example, and as Julia showed, to move out. So that has been one of the great things. The other thing is success is sitting here together as part of this concept of campus as a testbed. It's a key element of the Climate Grand Challenge project that Miho is leading, that I'm a co-advisor on. And then that part of that success is we're going to be continuing to look at the campus in a number of areas, moving to more regional, to Boston and other areas, and then going out around the world. So that has been one of the important things of bringing faculty together through this. And as a researcher, using the campus as a testbed has multiplied 3 to 5 times the count of money that you get to be able to get an NSF research grant to do the things that Katya has been doing with the campus would have been in the $1 million range. And having the support of people, and part of it, for me, success, my entire career has been making research into action to fight poverty or do things related to justice. And that's what's been able to happen as I worked with my colleagues and learn what are the questions. And that's also what is part of the Urban Risk Lab, is what do the people need and how do we bring it to them through science and not just science for its sake. And Miho has led that way. So this has been part of it as well.
And Miho, success? I mean,
yeah, I agree with a lot of the comments, and thank you, Ken. I think that some of these projects, they have an impact on campus with students, but then also the tools that we built can then be shared much wider. And then the papers, of course, have a large impact within the academic communities, and then other types of publications hopefully have impact beyond that. So I think that's one thing. I think one thing that I haven't been able to do yet, but I hope to do with Laura and Todd and their team, is to connect some of these projects to then classes that get taught annually. And I think that that would be the next step that I would like to see these types of projects then grow into. And I think it's already been done through Julie, but I think more of that can be done on campus too.
and what about challenges? You've all had a lot of success, and in terms of where you'd hope to go with it, what have been some of those barriers or challenges that you're hoping to overcome, and how might you overcome those?
I think one of the issues is the challenge also has led to growth is data. And if Joe Higgins is in the room and Julie, it costs a lot to do things correctly. And learning when is just enough. We never have enough money, particularly working in developing countries. There's never enough to do what we want to do. But on campus, and as an alum, I don't want another letter saying, could you triple your donation because we have to do a basement survey. But understanding the needs and the limitations of budgets and time of staff on campus, and how do we get the data? So, so we turned, a lemon of we can't get any data to a lemonade to engage students, both with Miho and the porosity hunt, and then Katya doing that to bring that in. And I think that's a model to that. But the challenges are usually having enough resources, and sometimes what's just enough to make a good decision on campus is not enough to be a publishable research. So when do you start, and how could we do a little bit more to make that ground break? But good problems to have.
Ippolyti, any thoughts on challenges you've encountered?
Yeah, I definitely agree with the data side of things. When I was doing modeling, there was a lot of issues trying to get the exact information because you need that for your models. The other thing is risk taking. I think that's a big challenge, is who is willing to assume the risk of testing a new technology if it's really, so technologies that stem from research are usually at the proof of concept scale. We have a lot of that on campus for like renewable energy or like zero emission solution, but going from that scale to actually implementing it is really hard because it requires a lot of investment and a lot of time and energy, and trying to find people who are willing to support that is probably the biggest challenge I can see. That's true both on campus and in general, I would say.
Yeah, I would completely agree with that, the risk-taking piece of it. And it's easy to do a campus as a test bed when it's just a 3-month project, but can that project then become a permanent feature within the campus, either in the landscape or within part of our buildings? And so I think I haven't quite reached that point yet, but I think in the next year or so, and working with all of you, trying to see which types of projects then belong on campus as a permanent feature.
Thank you. Maybe we'll kick it out and see if anyone has a burning question or wants to weigh in. I don't see any hands, but if you do put your hand up, I know Don has a mic, and then also Anushree up in the front. So, yeah. And if you could just maybe say your name, where you're from, and pose the question.
Hi, Kurt Newton. I'm director of MIT OpenCourseWare and very passionate about these sort of issues. Thank you. I'm curious about what you might be observing about the work that you're doing on the local testbed with connecting with other universities and with cities, that many of our schools are situated in. Obviously, as wonderful as the work we do here locally is, I think we're all interested in the 100-fold, 1,000-fold impact of how this is actually disseminated out there. So anything that you've been seeing in that direction that you could share, I'm really interested to hear.
Thanks, Kurt. Anyone want to jump in?
Talk about the so in terms of Cambridge in flooding, 10% of Cambridge is MIT, and as we said, there was an issue related to modeling our campus. But in the process, Katya Boykin, who is here now, demonstrated that the traditional techniques of modeling stormwater in cities that Cambridge was using left something to be desired. So we showed how if you use what's called rain-on mesh, you can get a more accurate sense of flooding. And so we've worked jointly with the city of Cambridge. We now have what we could call a harmonized model. So Cambridge has MIT properly modeled in their model of the whole city, and then we have to the boundary conditions of the catchments that affect the campus. So we're working together. And then also as we move out through some projects, what's going on here, both Brian and I have been able to contribute to the city of Kampala in Uganda on how to approach flood risks and the tools that we're doing. And there has been some exchange on that, as well as taking a lot of these lessons to our activities in other places. So that has been going on.
Miho or Ippolyti, any thoughts?
Yeah, I think also what Ken mentioned earlier, that we're both involved in this larger Climate Grand Challenge project, and that is really, in the next few years, meant to be about disseminating and sharing tools and modeling techniques with a variety of cities. And then on a smaller scale, our lab collaborates a lot with like community groups and especially the farming communities around Boston, and local neighborhood groups that are involved in a lot of climate action. And so I think that that's another way it's not so much like disseminating, but really collaborating and partnering with them and learning their techniques as well.
Yeah, in terms of policy at least, I think that a lot of the legislation, both at the federal and at the state and city level, is very opaque to people. So just being able to go through that, finding the key takeaways, and then understanding how you can implement it. If you understand how you can implement it at the scale of a campus, that's already huge. And then you can translate these tools to, implementing it in other cities, and pretty much anywhere. So yeah.
Thank you. Anushri. We'll get a mic over.
Hi, I'm Anushri. I'm a third-year undergrad in DUSP and Econ and a previous student researcher with MITOS. My question is a pretty close follow-up to the previous question. I think something that's been very actively talked about in the international climate community is the focus on active citizen empowerment and how to actually engage the people who are directly affected and have lived experiences related to these very complex issues. And I'm wondering, given the campus as a testbed model and how much we've relied on students and just the people who live and work at MIT to partake in a lot of these research projects that you've mentioned, how can we translate the insights from that into empowering citizens, starting with our local Cambridge and Boston area community, but also in other areas? And how can we ensure that we do participatory research and kind of shift those models over without compromising the ownership of communities in that research?
Thanks, Anushri. Thinking of the Dellatolas.
Yeah, I was just... no, your point is really well taken, and it's something we've been thinking about quite a bit. And another person who should be here is Elizabeth Shepard. She's been working with Brian and I on trying to create a climate core initiative. And so the idea at the moment is that we would try to establish an MIT climate core, so student group that really then helps with projects on campus. But then we're closely partnered with another organization in East Boston that has a youth climate core starting this summer. And so Elizabeth has been helping them structure that program, and then we would want to do some pairing between MIT students, and the organization's called East Farms, but really pairing the need for green jobs, youth and their education. We did a series of interviews to understand what the opportunities now are and what their interests are, and there seems to be a really great fit. And then also having MIT students within our climate core here then partner with them and learn in both directions. And so I think that we just received the Dellatolas grant to do that, and we're starting off this week, next week, very soon. So yeah, I would love to share information about that in the future too.
Thanks. Any other questions from the audience? Yeah, we have Nick. Oh, Yuli.
Hi. I'm Dr. Fuentes-Medel. I work in MIT. I'm the program manager of fiber technologies. So I'm the one from fashion industry, relating to industry. It was back to what you were saying, the engagement piece. So how do we make that this is happening here and everything, engagement of, how do we hit home to us in terms of what is happening here can happen in other places? And how are we using more of the people in the Institute of behavioral changes that need to occur at the human level, which is something that we find intriguingly important for, this has to hit me, therefore the building has to change, therefore the community has to change. So curious about more like how do you, maybe it's an ambassador program, like I am the person in MIT that is climate or whatever, but something like that, that I don't know if you have been thinking about the behavioral change that has to occur.
You're talking about kind of behavior change on the campus as a result of the work?
Well, what we do here will impact the world, right? So how do we kind of also learn of the behavioral changes that are happening here to impact the rest of the communities? I guess that's the core of the question.
Thoughts?
Well, I'll go on part of it, get you ready, but one of the things that we have learned, and I think the campus operations have showed you, is you have to listen as a researcher, but also as someone who does a lot of policy on the other side, is listen to where people are now so that you understand how they deal with risks. The word came up. This is all a risk problem. And how people deal with risk is quite different. And even on MIT, we can say there is not a top-bottom risk profile. And each group can be out of balance with how they deal with risk. Some take it benefit cost, some do things that they teach you in the Sloan School, others do things that grandparents have taught them. And so it is a cultural aspect. So listening and hearing, and then the big word that made everything possible here, and I attribute this to Julie and Joe, is trust. Bill Kohlhauer, who may be here, handing over his entire data set on MEP that I could easily use in a way that would hurt him, but he trusting that we were using it in a way as a partner. So I see that on the campus, I see that in Kampala, I see that in Mumbai. If you're working with people to make change, you're not coming in with answers. You have to come and listen and then provide solutions that fit, because there's so many different constraints. There's technological solutions that are inappropriate or just out of budget, and how do we move along? And a great thing a colleague shared is we have to have the mindset not of Freddie Mercury, I want it all, I want it now, but of Mick Jagger, you can't always get what you want, but you get what you need. So that's sort of part of our work with dealing with them. But that's not a social scientist. So Miho?
Or Ippolyti? Thoughts?
On the behavioral change side, I think that there's a lot of, the Harvard had proposed like this competition between labs to show who achieves the most emissions reduction, and then they had a big reception or something for the winners. So there have been solutions that were proposed kind of like that, but to me it's more about being able to demonstrate that emissions reductions are possible, and that goes back to what is a successful project. On the public engagement side, I definitely agree with what was said. It's about listening to people's both concerns, but also ideas. There's a lot of student initiatives, and that's kind of what we're working on now, is trying to be able to scale these up to support the students to, be able to follow through from the idea to the implementation of the strategy. And once you do that, then you can also share, the results of that and like empower other people to do similar things.
Yeah, behavior change is hard. It's like, even just with the recycling, we have the world's smartest kids here, and why can't we just put things in the right box? But I agree that there are a lot of ways, like in our lab, we had a little competition to see but I've heard that these kind of competitions with the student groups make them turn off the heating in the winter and do really drastic things just to win. And so I think, but something like the ambassador program, there are many, I would love to hear more suggestions too to how we can start. And I think personally, I find just exhibiting your own behavior change and modeling that. And because it's all about time, right? Like if you just had a few extra seconds, then you can start to make improvements in all of this. And I think the other thing is we've hidden all of our infrastructure systems. We sort of try to make everything seem seamless so that there are no issues until something breaks and then there is an issue. And so maybe opening up transparency, daylighting some of these processes so that students can engage in them would also be a way. But I think, yeah, we collectively need to keep working on that.
And just to add to that, one reason why behavioral change is hard, or something that I've heard a lot here, is that I can do something, but the institute is not doing enough. So if the institute is not doing enough, then why would I even turn on the lights or turn off the lights when I leave a room, for example? So showing what the institute is doing and showing that you as an individual can have an impact at the scale of the institute is also super, super important.
I think we maybe have time for one more. Yeah, Nick, one or two more?
I'll try to be very quick. So thank you for the research that you've done both for the campus and beyond. My name is Nick Hambridge. I'm the Institute Risk Officer in the Risk Management and Compliance Services Office. So I have kind of a two-parter, one on the flood analysis and one on the heat analysis. So you mentioned, you know, if you had more resources, we could always use more resources. If we did on the flood analysis side, what would be the additional kind of enhancements that we could make there, or are there any? And then on the heat analysis side, I'm interested in what are the risks that were identified through that analysis. So we heard about basement flooding as a major risk from the flooding side, but how about the key risks on the heat side? Thank you.
So on flooding, just off the top of the head, I think Katya's here and can add to that, but the understanding the basements at MIT and their elevations, and that would be one of the bigger things we've identified. That's it. And how water will move from building to building needs more data and more modeling. So that's one area. But to make a decision, we have enough to move forward in the work that Brian and Laura and Bill are doing. So, and we're working with the Office of Insurance. But on that, the other thing is helping to set standards of risk across new buildings, renovations, and those kind of things. Is there a standard, like in the government, we have FEMA, the 100-year flood is a standard that's used. Is that something that we want to do? So more work in that area, and bringing that seamlessly across is something we can do. And in the heat, there's an activity going on right now, and some others. Maybe Brian, you want to talk about that, or?
Yeah, maybe, and we'll have to close it out in just a second. So Nick, we can certainly follow up with you. We have some heat research ongoing with the Sensible City Lab, as well as another student from mechanical engineering, and we have some early findings about hot spots on campus during the summer. So we have that information that's hot off the press, and I'll get it shared with you and others who are interested. And just any final thoughts on Nick's question, Ippolyti or Miho?
I can share the heat. It's an analysis on all the facades on the buildings, yeah, and the heat risk to anyone working within them over the summer. So we'll share that data together as well.
Well, I just want to thank the panel. Round of applause. We've got, I think, more questions and not enough time, and that's the beauty of research here. So to be continued. Certainly invite anyone to follow up with any of the panelists. If you have additional questions, they'll kind of be here throughout the day. And if not, you can always connect with me, and I can help connect you to any of our panelists. So thank you, and thank you, audience, for your questions. In terms of next steps, we are going to have a break in just 30 seconds. I'm standing between the break and you. There's something really fun. It's called Sustainability in Motion. This is Julie's Sustainability Aerobics. It's coming up next. And so we're going to ask, let's see, the folks involved in Sustainability in Motion, if you can come to the room after you get some coffee. And then as a group, we're going to reconvene here. Is it 10:30? Is it 10:30? So please be back in your seats at 10:30, because it's kind of like musical chairs, and you don't want to miss your chair. So thank you all. And now enjoy the break, some coffee, and I will see you in a few minutes.